Hello, everyone. My name is Paweł Tomczuk. I'm the co-founder and CEO of TechTree. Today is a special occasion. We're partnering with TechNation, Upscale program. It's an amazing organization whose alumni are some of the most recognizable brands in the tech ecosystem in Europe. So it's amazing to be partnering with them. And of course, Show the Code series is brought to you by us in cooperation with Silicon Roundabout, one of the biggest communities in London. I think over 14,000 mid and senior engineers. And Francesco, who's the co-founder of Silicon Roundabout, will join me in a moment. The goal of the event for us is really to put the engineers who are building the tech companies in the spotlight, because we constantly talk about the tech community and tech companies and tech sector, but we rarely give the stage to tech people who are building these companies. And we hope that it's going to be an interesting hours or so of listening to people who are behind these great products, listen about the challenges they're solving, and simply ask them questions about what they're up to, etc., etc. All of these companies are hiring massively, so if anyone wants to reach out to the speakers after their talk, I'm sure they're more than happy to carry on with the conversation. It's good to see Francesco joining. We have a number of partners. So Francesco, the floor is yours. Great to see you.
Hi, everyone. I'm Francesco, one of the founders of Silicon Roundabout. Already Pavel introduced us, one of the largest tech community in Europe, based in London, and now spreading even bigger thanks actually to the online world. So we're going to keep a hybrid approach, but also look forward to bring back the live events once the lockdown ease. And we're really pleased to work with TechTree on these events because, like I said, all the time, if you have come before, you'll hear it again. I'm an engineer myself. And even though we're in the business world of startups, effectively startups are built with tech. And many times events and communities that are about startups give the stage to companies to pitch to investors or the general public on a business perspective. And then, of course, you've got the more niche meetups for engineers, which is all about maybe like bits of codes, but the two rarely come together. So it's a great opportunity to see how we as engineers, the builders of tech, actually create startups alongside the other side of the business, and we actually build new technology. It's also great today to be here with TechNation, because I always feel like we are kind of cousins in a way, them being almost the scale-up community of the UK, where we tend to be more like the Hacky Founders early community. And many of the startups that come to our stage end up flowing into TechNation at some point, like the Monzos and Zigus and unicorns that pop up. So a great event today. Really look forward to get some tech going. And if anybody's got any questions on the community side, want to join Silicon Roundabout or want to know more about the events that we're doing, I'm just going to put our website and my LinkedIn as well. Feel free to connect. But other than that, just thank you all for joining, and really look forward to hear more on tech from the founders here today.
Yeah, and may we welcome our amazing partners from TechNation. Well, it's great to have you here today. And I think, if you can maybe give the audience just a little bit of an overview of, TechNation and the Upscale program, that would be amazing. And then we would be welcoming our amazing speakers.
Yeah, absolutely. Paolo, Francesco, thank you so much for teeing up the intro there. And hi, everyone. Thanks so much for joining today. Really excited to be partnering as TechNation with TechTree and Silicon Roundabout to deliver this awesome event. Not going to take too long on the introduction because the really exciting stuff is to come. I'm really excited to be able to facilitate these 5 companies presenting today. As an organization, TechNation we support the UK's most ambitious entrepreneurs and senior leadership teams across their scaling journeys, as Francesco mentioned there. So from early stage right the way through to late stage, we really wrap programs of support around teams who are building some of the most exciting tech companies in the UK, and really helping them to, I guess, get support on their key scaling challenges. Anyone who's worked in, I guess, tech over the last few years will know that hiring exceptional talent is the biggest challenge for tech companies. And so we've really been looking for a way to better support our companies with their hiring challenges. And what better way, I think, than to open up, I guess, the hood on these 5 brilliant companies and show you what they're working on, and really give you the opportunity to understand the kinds of challenges that these companies are facing. I'll let them all introduce themselves, but really, really excited to see this today. 5 of the most exciting companies on the Upscale program, which is our Series A stage program. I will let Ollie introduce the visa program that we run here, which is going to be relevant to many of you as well. But just wanted to say thank you to Francesco, thank you to Pavel, and from everyone at the Upscale program. Really looking forward to seeing this event today and to continuing the partnership. Thanks, everyone.
Thanks a lot, Liam. And yeah, Ollie, I think, the visa program is something that is absolutely critical for London, because every time we speak with a company, they just can't hire engineers fast enough. And I think what you've been doing for many years now have been amazing. I've met some of the alumni, absolutely fantastic people. So I think if you could speak, just give a brief overview, that would be fantastic.
Yeah, really happy to do so. And thanks so much, Pavel and Francesco, as well for sponsoring today. Really pleased to be a part of it, and Liam for such a seamless introduction to Tech Nation Upscale. So I do not need to go over that at all. And really glad, Pavel, that you mentioned like the positive experiences that people have had through the visa program already. I could talk about it for a long time, but that's not the point of today's event. So I'll hopefully just in a couple of minutes give a brief overview. And I'll share some links on that, and happy as well to connect with anyone on the call as well if we've got any more questions about the visa process. You're right there, it couldn't be more important a time to have a visa program like this to make sure, particularly from our UK perspective and UK tech scale-ups, that you get the access to the best talent from all around the world. And our visa program, we think, is one of the best ways to do that. It's different to any other kind of visa that you will have heard of, particularly in a UK context, where typically visas are kind of sponsored or associated, particularly with your employment, with your employer. This visa is not the case. It's completely unique to your background. That means that you could apply for the visa if you haven't got a job at all, or if you're looking to make a job move, or you want to go to work for a company that at that moment cannot necessarily sponsor a license for you to work. All of that is available and possible through the Tech Nation visa. We refer to it as the Tech Nation visa. Its official title is the Global Talent Visa. They are the same thing, for the avoidance of doubt. In order to be able to get a global talent visa in the UK, you have to get an endorsement, and that's where Tech Nation's kind of role comes in. It relies on, and the Home Office effectively outsources its tech expertise to us as Tech Nation, and we have an independent panel of assessors that effectively decide whether or not you meet a criteria that you are a leading talent in your field, or you have the potential to be a leading talent in your field. And that really is the kind of prism and the view of which all the decisions are made. It's not the easiest of processes, but that's kind of deliberately by design, that it's, you're supposed to prove that you are a leading talent, but it's also not too difficult compared to, I think, some of our competitors across the land, outside of the UK, or in other processes. So once you go through the endorsement, if you're then given that, you're able then to go ahead and get a global talent visa. I think one of the main benefits beyond its flexibility, is that it can also be a fast track to settling here in the UK, which I think is a major plus. So what I'll do after this is send some links in terms of what that process looks like, and help them to understand that. But Pavel mentioned before, we've been doing this for, I think, 6 years now. We've got a growing community. There's nearly a couple of thousand people who already come through the visa route, who are doing some amazing things, whether that's part of other scaling organizations or at some point founding their own tech businesses. And beyond just supporting each other professionally, there's a real kind of personal support, adapting to UK culture, all those other things as well that are going on. It's a really brilliant network. So reason alone, I think, to come through the visa route. So I'll send those links to it. Please do reach out afterwards if you've got any other questions. And in the meantime, I hope you enjoyed today's event. Thanks so much.
Okay, so now is the time to welcome Marco.
Okay, so now, really nice to be here. I'm Marco, VP of Engineering at Riverlane. What I'm gonna, I'm an engineer. What I'm gonna talk about today is what the quantum computing and how exciting it is, at least for me and for everyone at Riverlane. I want to start with something that is probably not familiar and move into what we're doing. First saying that you're not aware of, you're probably aware of lots of really complex mathematical problems, and what's so-called NP-hard type of computations. And what you think of is probably bitcoins, portfolio optimization, apparently Pac-Man, as I discover. But these problems, as in particular Pac-Man, doesn't really have much application, much impact in your life. There are other problems that have the same sort of complexity, and they are really challenging. And they do have an effect on your life. I'll mention two. One is, interestingly enough, is the fertilizer production. So globally, we consume about 1-2% of all the total energy to generate fertilizers, global energy. This process is particularly not effective in terms of energy requirements. Tiny prokaryotes in the soil can do that at under 1/100th of the energy required, but we don't know how. We have ideas, but our simulation of the process is not good enough, so we can't really recreate the same process in our labs. This is considered an extremely complex problem that is quantistic nature for different various reasons. And similarly, another one is drug development. So drug discovery is about estimated that it takes 2.6 billion to produce a new drug. Most of the cost is in the initial stage and of the discovery, then the human trials, the animal trials, etc. Failure rate is really high, and this because there is the modeling of the proteins, of the enzymes is not up to the task. And this is again because it's, lots of quantistic and atomic properties of this molecule are affecting the process. As you can imagine from all this mentioning of quantum, how quantum computers can help. They can in looking at these examples or similar examples. If you have a problem that is what is called with exponential runtime, so the time it takes is a function of the number of inputs or the size of the input. You get something like this table. So classical, not quantum, will take the age of the universe. This is probably an example that relates to factorization of prime numbers. And a quantum computer can do that in 25 minutes. So obviously, it's a special type of problem. There are lots of problems like this. And watch out here, because this was my initial mistake before joining Riverlane. Not all the problems are like this. So there is a set of problems for which a quantum computer on the right is a monster, is the fastest thing that can go. But there are problems in which you want to turn, steer, park, and the computer, the classical computer on the left, is much better. So quantum computers are really effective in a set of problems, and there are different speed ups that you can achieve. So this is like sort of the pyramid of performance gain that you can get. And at the top at the pinnacle of this pyramid, there is things that are really accelerated by quantum computers exponentially. And at the bottom, there are things that are accelerated by a factor of 10, 100. And we do care a lot about this bottom of the pyramid, because this is where you find stuff that make drugs discovery possible, that makes the fertilizer production more effective. And this is where all the pharmaceutical company and all the money are now initially moving. So we are in what's called NISC era. So we are in a phase in which quantum computers are still clumsy, and what they can, and we are in the yellow area. We are moving towards the green one, in which there are applications that can already benefit from quantum computers. And then we will be in the blue era in 10 years' time, in which all the applications that need a ultra-fast supercar are possible. Now, just to motivate the yellow, green, and blue, there are some roadmaps made public by IBM and IonQ. IBM, IonQ is the biggest company, the second biggest company in the US quantum computing wise. They have quite a large portfolio of machinery and applications, and they both claiming that they will reach this stage of being able to do something commercially important and effective in about 5 years' time. The investment is exploding, so we are about 1 billion, and this is from 2 years ago. So numbers keep kind of doubling every year or so. And hoping this is an appetizer, a good appetizer for you now. Where do we sit? Where is Riverlane? What do we do? So Riverlane is traditionally a computational chemistry-based oriented company. And our goal was to get to tick all these boxes and do cool things with quantum computers. And then we discovered that the software was not good enough for us, and then we became a software company doing quantum software on top of chemistry. So what do? Is we trying to work with all the possible quantum computers in the planet. There are about 32, let's say, commercially ready quantum solutions, and of different type of technologies. Completely different constraints, completely different problems to solve that they can solve, and problems that need solving to make them viable. And they all have in common the similar structure. That is what makes the engineering part of working at Riverlane super exciting. They have these ultra complex heterogeneous systems with CPUs, programmable logic, so FPGAs, custom logic as ASICs, superconducting logic, optical, radio frequency, everything you've seen in a book in engineering is kind of needed. And but they share this heterogeneous structure, and this is important to us. And what do they share is also the concept of wanting to implement quantum operations. You might see these pictures in my slide, but the idea is that there is a big branch of quantum computation that is still looking at numbers and operations and formulas. This needs to get close to reality and work with the hardware. So we are creating this connection between writing formulas and getting them to be executed on a quantum machine. So, for example, this lovely music chart is in reality a tiny, really, really tiny way to characterize them, and is only part of it, to understand the energy of H2 hydrogen molecule and the way that the electrons are interacting, and that can be done with a quantum computer. Obviously, this music chart is much longer. All these blocks are something that in the Google chip that is on the left, the Sycamore, becomes something really electronics focused and driven by lots of different hardware and software units. And this is just the beginning, because then people understand that to operate these machineries, we need to reach the same level of correctness that you have in your current system. And so they need error correction. They need a way to trust the data. And this problem is much more tricky than in classical, and is something that there is no framework yet to do so. But this is where we stand. This is what we do. We try to tackle the focusing on chemistry and materials. We are trying to develop all this framework. So from the top, we understand that we have small quantum computers now, but we can mix and match quantum computers and classical computers to get the best of both worlds and show that we can build and simulate better existing things. So in this case, we are simulating part of a molecule with a quantum and everything else with a classical machine. We want to allow all these hardware companies to win, because we believe in a democratic market in terms of hardware companies. And to do so, we have developed our framework for testing, developing, and targeting these heterogeneous systems. We do run on hardware. So this is a lovely scan from our friends at Oxford Ionics, in which we run an experiment on their quantum machine. Nothing crazy. And the cool thing is what we have done is all our code is Python-based. So we use the power of simplicity of Python, make all the physicists happy, but by leveraging these capabilities. And we want to move to a new paradigm in terms of controlling these complex quantum machines with our control stack. We work with the last thing that we do is, well, one of the last public things we do is to work with all the hardware companies in the UK, the quantum hardware companies in the UK, and we are trying to design the new API, let's say, that is needed to talk to quantum computers. As you can imagine, we are growing and we are looking for people, so please do check our website to see if there is any role that you might find intriguing, and give us and send us a message. That would be really appreciated. And here's my mail, and thank you.
Thanks for your talk, Marco. That was really interesting, kind of a sneak peek in how some things that are quite important for us are happening. Now, I'd love to welcome Deepak on the stage. So without further ado, the floor is yours.
Thank you very much. I'm going to go ahead and share. So my name is Deepak. I'm the CTO at Redshift, a cybersecurity startup here in London. And today's sort of topic is very much what's in trend, serverless architecture. But I'll sort of go into why we picked it this way, and also give you a glimpse of how we think about architecture at Redshift. So very quickly about myself, like most of you in the audience, I started my career as a developer. I still do a lot of hands-on coding. It's always exciting to do that. So I've tried to make the talk as exciting as I can for you. I started my career in the early 2000s. C, C++. So a lot of my time went into really waiting for compiling. Fortunately, that has changed a lot now. I don't think I need to wait for longer than a few seconds these days to get my code out. I've worked at various startups and a lot of big companies as well. So sort of that has shaped my perspective on how I think as an engineer, and both in the startup world and enterprises. Notably, Opera Software, the browser maker. So a little bit about Redshift. We're a cybersecurity platform. Underneath the product company that we are today, we're very much focused on email security, and we have 2 flagship products that sort of tap into help companies strengthen their email security. But underneath all this, we actually have a platform as a service, so you can actually build data-driven applications focused on cybersecurity on our platform. It's not yet public, but that's our long-term vision, to be able to invite build an ecosystem and a marketplace around this. And the way we've built our platform is very much inspired by the big data world. So you're actually working, a lot of you are familiar with GraphQL as well. So that's how your backend today for all our products is constructed. Data starts somewhere and then flows through a graph and then becomes something else by the time it comes out from the other side. So you can think of operations like MapReduce, scattergather, or even simple aggregations. So very briefly, as every startup should, we started very much as a monolith. It was a big Node.js application that probably took us through until 2 years. We didn't really have to do anything special there. But once we started feeling the pain, we of course started our journey towards microservices. And of course, it always sounds like a great idea, but then you start to get into the nitty-gritties, and you start to see how it's not as simple as you thought it is. So that started roughly around 2015. We're pretty much still on that journey. We're not truly microservices yet. I like to call this stage the microlith. So we have the microservices, but we're still relying on a lot of centralized databases and services that keep it going. And of course, it's never easy, microservices. So you really want to do it only when you have both the resources and the need to do it. There's really no point in trying to prematurely get there. You want to stay on your monolith as much as you can. Our stack is fairly non-standard because we are on IBM Cloud. What used to be SoftLayer, the reason being we're a platform as a service. So our bare metals give us. We sort of rent bare metals from IBM Cloud and then layer our infrastructure on top, because we do a few things around orchestrating the various computes that we need within our platform. We of course use Kubernetes to orchestrate the microservices, and predominantly our backend is written in Go, but there's also Node.js and Python, which sort of augments it, and front end is entirely in React. So, coming to today's talk, and what we faced within our product was the classic. We needed to provide our customers with the ability to search within the product, and of course your classic approach to it is to put up an Elastic cluster, which works very well. But we wanted to, because our platform was very much built in the serverless architecture, we wanted to see how that would sort of work for us here. So the problem statement was we needed full text search and indexing. It had to be multi-tenanted so that data from one customer is not mixed up with somebody else, and it had to be sharded for the same reason. Your customer's data had to sit independent of each other. So that's why we started, and we said, can we build something on our platform in a serverless way, and would it actually work without having to manage a cluster? So the reason to not have a cluster was mainly around operations. We already had a lot of operations from being on bare metals, having to layer Kubernetes on top of that, and then managing our infrastructure. Moreover, we wanted to move this problem from becoming a platform problem to stay within the product team, so that they could then manage this on their own without needing the expertise of the platform team. So we stumbled upon an embedded key value store. It's very much like a SQLite, which lets you have an embedded SQL server inside. So it's called RocksDB from Facebook. So it's a very popular project, historically built on the back of LevelDB, which was one of the first sort of the key value stores that came about. And the third reason being, we wanted to be self-contained, so that there is no search is not a 24/7 problem. People are not going to search on your platform for all the time. So that sort of blends into the serverless model. You start a function when you need it, you do your work, and then you're done essentially. So the ingredients for this recipe essentially turned out to be RocksDB, which is the embedded key value store I was talking about. We picked up a Go library, which actually does the full text search and indexing for us. We had to layer a few things on top, but essentially the basic building blocks were available. Pretty much similar functionality to Elastic. It provides various types of attributes that you can index. You can have terms. You can have free text search. You can have tokenized search. Of course, you can search through emails and domains, etc. So quite powerful. And infrastructure-wise, fairly simple. You just need a POSIX file system to sort of orchestrate the whole thing. Nothing fancy there. Whatever you send to RocksDB is essentially persisted on that file system. So very briefly about RocksDB, it's a Facebook open source project. They picked up LevelDB, but then realized for their purposes, it wasn't as performant as it could be. So they essentially rewrote it. And it's written in C++, so very portable. High performance, it's optimized for fast storage. We use SSDs, of course, to actually persist this. It's very adaptable as well. And of course, it does come with some constraints. The main constraint being you can only write from a single place. And that actually blends very well with the serverless architecture because your function is invoked, can write, but then you can read from multiple places. Blev is the full text search and indexing library I spoke about. Very simple API, very JSON friendly as well. You can index any object within your data model. It's easily extendable. We had to extend it to sort of support IP addresses because that functionality wasn't present in there. And file system, very simple. We just picked a network file system, mainly because we had to share it across our cluster of nodes. But the bottleneck is really your input-output operations on this. So staging, of course, we just picked a 200 IOPS, which is plenty. But on production, of course, to support our scale, we have about 10,000 IOPS today. And this is very extendable in the future. NVMEs are out there, so they support millions of IOPS today. So it's very easy to scale this. The only customization we had to do was supporting the IP address because that was one of the attributes we had to index. So being able to store an IP, but query on the basis of a subnet. So saying that give me an IP within this range. But also supporting IPv4 and IPv6. So fairly standard problem. We looked at how the other libraries did it and sort of implemented a similar one within the Blev library. There's no time for a demo, but I just gathered a little screenshot. So this is sort of where it sits within our product. There's a simple text field that sort of drops down various attributes for you as you search. There's also some deep linking, so you can come back into this interface with specific search terms and filters. And then what this does is fires off an API to our backend, which then invokes a function which starts and then has access to the POSIX file system I was talking about, and then can query RocksDB via Blev to give us the results. So, the prototype itself was fairly straightforward because our platform supported the serverless model. Unlike AWS Lambda, we've baked in sort of both persistence and it's easy to invoke other functions from one function. So because of that functionality, you can actually write some very advanced sort of data processing pipelines on our platform. So in that sense, this problem was perfectly matched for the solution. We were quickly able to prove that this sort of works. We've even written a blog post with sort of more technical details if you're interested. But once we had this, we of course ran into issues within production, of course, because whilst the single writer is fine, it just doesn't scale. So for our larger customers, we had to think of better ways to sort of scale this, and sharding is obviously the best way to do this. So we looked at tweaking both batching and sharding. So batching is when you can write a bunch of records together into RocksDB instead of writing it one by one. So we collect it and then we dump it into the database. And sharding is where we can actually sort of be clever about the single writer problem. It's a single writer, but if you can write to multiple partitions for the same customer, but then be able to read all the 5 partitions together, 5 or 6 or how many ever we configure as one unit, then we've solved that problem, because then there can be 5 or 6 writers, increases the throughput when you're writing it, but then when you're reading it, it doesn't have to care about trying to do anything fancy there. It behaves like those 5 parts come together as one single unit. And then of course our vertical limit was essentially the disk saturation, how many IOPS you actually hit it with in parallel. So what we did was very quickly benchmark various values of batching and sharding to see where the sweet spot for us is for our setup. So batching will increase the throughput, but it doesn't saturate the disk because you're actually writing in one go. So instead of writing 200 single records, if you do 200 of them together, that's essentially one write. And sharding, of course, allows us to increase the throughput, but of course it will saturate the disk because you're doing many parallel writes in the process. So this is sort of what we ended up with in terms of the benchmarks. So you see various combinations of batches and then shards being used. So these various colors are different batch sizes that we tried. So 20 all the way from 25 to 400. And the x-axis is essentially telling you how many shards we tried. So shards is individual pieces that we can write to. And on the y-axis, you see the throughput that we achieved on the back of this. So it escalates quite quickly and then starts to saturate. But for 400 batch size, we saw that it quickly degraded because you're trying to do too many across too many shards. So we roughly sort of settle down into whatever it was optimal for our use case, and we tweak this today as well. As we see it change a bit, we can do new benchmarks and then sort of tweak it to give us the best performance. So serverless, we didn't merely want to do this just because serverless was the way to do this. We have bigger ambitions in sort of like I briefly mentioned, we're pretty much a microlith, so we are still going to a central NoSQL database. So we wanted to use this experiment as a way to test if, for our application database, can we actually move away from a NoSQL cluster into a more, serverless plus embedded database approach that I briefly explained here. So for us, this experiment was quite monumental because it showed us that our thinking, our architecture around serverless sharding actually could work for us in the long term, in truly sort of going into microservices, where each of our services are essentially independent of each other as much as possible, and they can sort of survive failures across the rest of the services. So the sharding that we do, there's 2 levels, of course. One at the customer level. That provides natural security because we're then isolating each customer's data. It's self-contained, so we've moved the problem from infrastructure operations platform layer into product. So our product engineers today maintain this instead of our platform engineers spending time on this. And best benefit for us was operations-wise. There's no cluster to maintain. When a search happens, the serverless function does what it needs to bring everything up, does its work, and then it's thrown away when it's not needed anymore. So hopefully that gives you a glimpse of the way we approach this. Very iterative approach. Of course, we're big believers in iteration. You want to get something small out, see all the implications, see if it works for you, and then sort of put in more effort to scale it. Thank you very much. We're obviously hiring for various roles, so please do have a look and then apply.
Thanks a lot, Deepak. Super interesting. There's one question from Ruslan. You can see it when you go to stage and you pick Q&A. He's basically asking Deepak, how significant percentage was change in performance when you switched to batching in RocksDB?
Yeah. So massive improvement immediately, and then starts to flatten out for a while, and then starts to drop very quickly as you go high. So for us, the sweet spot was roughly 100 to 200 batches of 100 to 200 for the sizes we were doing. And RocksDB is actually pretty bad beyond, I think, 100,000 records in general, because its main drawback is it keeps the keys and values together. So you're not able to optimize things because it has to pull out the values as well. So batching significantly helped up to a certain point and then quickly degraded. So it's very essential to carry out benchmarks to see where your sweet spot is.
As the next speaker, it's going to be my pleasure to announce Tom Loke. Tom is a full stack engineer at Unmind. So Tom, yeah, you there? Thanks lots, Deepak.
Cheers.
Smooth handover. So over to you. The floor is yours.
Hi, I'm Tom, and I'm a full stack engineer at Unmind. Today, I'd like to talk to you a bit about the work my team is doing building an analytics platform on AWS, a high-level overview of the tech that we've chosen, and what we're learning about as we go. So, who am I? That's the side of my face when it's not covered in a lockdown's worth of hair. I've been a software engineer for around 5 years, and I've been at Unmind for about 9 months, so roughly one lockdown baby. Unmind itself is a workplace mental health platform which helps employees in organizations look after their mental health proactively through both our web and mobile apps. This can be through self-guided programs, helping with things such as building resilience, managing conflict, or overcoming burnout. We also offer several quick in-the-moment exercises that we call tools, covering topics like getting to sleep, increasing your focus, or just basic yoga. These features can be audio, video, or chatbot based, with usage and completion recorded. We also offer periodic questionnaires, which people can use to track their mental health over time. From the employer side, we provide anonymized, aggregated data so organizations can understand how their people are in a way they never could before. So as you can imagine, this leaves us with not masses, but actually quite a reasonable amount of data that we need to use. At high level, we have two sources of data that come into us. There's data that's input into our app. So this is primarily through using features like completing questionnaires or using diary-like functionality. Then we have analytics data, which is the kind of thing you'd often collect through Google Analytics. We use a suite of tools for this, and to bring them all together, we use a tool called Segment. And right now, the main way we use this data, the analytics data is used by our product teams to ensure that our features are working the way that we expect them to. We use this data to build out reports, which goes to our clients on a regular basis. And we also use this data to build out white papers and participate in research studies. Moving forwards, we have aspirations to plug this data into machine learning models to power things like recommendation engines. So we've been around for a few years now, and whilst we managed to pull this data out when necessary, we've got a few things that are going to become a bit more painful as we scale. And we've got to the point that we need to address them. So currently, our data is spread across multiple databases using different technologies. This requires a lot of knowledge of our inner workings, and it isn't the simplest to work with. We really want to have one place where we can access our data. So like I said, to get that data, we have to get it out of multiple databases. Unfortunately, one of those is actually our production app database. So this has worked so far, but again, as our user count increases, we don't want this loaded on our application database. Additionally, whilst we're confident in our data security, having this data outside of our application database will give us an extra level of isolation with regards to who can access it. And to get the data out of that database, the only way to currently do it is through SQL. And as we mentioned, while we like our data team to not access it from our production database, on the other hand, we really like them to be able to pull this data from data stores suited to big analytical queries. Additionally, our internal teams, so teams like our sales teams or client success teams, they don't have a way to get hold of this data themselves. They cannot self-serve. And we only have a limited amount of resource that we can dedicate to those teams to pull out this data. That resource is quite often product engineers who could be making more features. And additionally, we don't currently have a single place where we store our business logic for working out what our calculations are and working out our metrics. So this leaves us with the possibility of inconsistent calculations if people are doing it in different ways. We really want this to be defined in one place. So work to address this was important. And the business was keen to devote resources to it, but at the time that we wanted to address it, we didn't actually have enough resource in our data team to do this. We did, however, have some expertise in our product teams. And so knowing this, we brought in some third-party expertise to help us. We have a long relationship with Scale Factory, an AWS consulting firm, and asked them to come in and do some workshopping with us. Now, I wasn't at these workshops, but you can kind of imagine how this went. It went down the kind of classic route of let's do the biggest thing possible and do the best thing, the most amazing thing, and get really overexcited. What you can see here is an engineering manager redesigning our entire app so we could access our data. Very quickly, we moved to something a bit smaller and more manageable, which would allow us to deliver value quickly. The consensus that we reached at the end of this was to try and leverage a technology called AWS Glue and S3 object storage to build out a data warehouse solution. Now, there's some jargon in there, but before we move on, I think it's important we talk briefly about what a data warehouse actually is. So according to the internet, a data warehouse is a repository for structured, filtered data that has already been processed for a specific purpose. So from a design perspective, what this means is the data is copied out of where it's normally stored, so like a production or analytics database, then processed or transformed, if you will, before being stored somewhere else to use. They're normally used in conjunction with reporting solutions, so the kind of thing that we'd really like to give to finance teams and sales teams. So after all of this, we finally got to a point where we had the first iteration of what we wanted to build. And what you can see here, we have two different domains. We have our platform domain and something we call segment. In our platform, our main application databases are in Aurora clusters. At the edge of that cluster, we have a read replica. Now, read replica is a copy or a replica, if you will, of our main data that we can access without actually impacting the performance of our apps. Beneath that, we have segment. So segment is, again, where we collect all our analytics data together. And whilst it is a cloud-based technology, we actually hold the data for it, so the database that has all this analytics data, on our own estate. We hold this in a database that's in RDS. So what we wanted to do was use a service called AWS Glue to manage ELT jobs, which would pick this data out and pop them into a data warehouse in S3. At the top of that, we put a service called QuickSight, which is AWS's point-and-click report building solution. This would allow our business customers, so again, sales teams, finance teams, etc., to be able to build reports. We'd also put Athena on top of this. Athena is a solution which allows you to run SQL queries over data stored in S3. Now, notice I said ELT job there rather than ETL. I also said data warehouse instead of data lake. We actually meant ELT at the time, and we meant data warehouse at the time. But this is a relatively good demonstration of getting everybody on the same page pretty early. The data warehouse and data lake are very different things. So I keep saying ELT, I keep saying ETL, and I keep talking about Glue. I think it's worth taking a minute just to talk about what those things are a bit. So If you have ELT or ETL, no matter what the order is, the letters actually mean the same thing. E refers to extract. This refers to getting data out of your original sources. In our case, our production database and our analytics database. The T stands for transform. So this is running whatever business logic or calculations you need on that data to form your metrics. So things like a weekly active user, a monthly active user. And the L stands for load. This is taking that transformed data and placing it somewhere else. So that could be into your data warehouse, for example. And we wanted to use AWS Glue to manage this for us. So Glue is a managed service in AWS that does the whole process for you. It will discover the shape of your data. It will transform it in any way that you've asked it to do so, and then put it somewhere else ready to be used. So that diagram before was pretty much the last step that we got to before we started work. We put a team together and brought in another consultant from Scale Factory for a couple of months to help us get started on this. That's pretty much when, as these things go, we discovered that what we wanted to build and what we actually needed to build were quite different things. So the first thing that changed for us is we changed how we used Glue. So the first thing we wanted to do is get something out of our production database and pop it into S3. We realized that Glue, whilst it was great at discovering data and building out your ELT tasks, having looked carefully at it, we realized it was a better solution for organizations that need to discover their data dynamically. The shape of our data doesn't actually change very often. Additionally, Glue ELT scripts are output or for custom scripts written in either Python or Scala. Now, traditionally, we are TypeScript or JavaScript shop. And these are Python and Scala are languages that our teams aren't really quite as familiar with. So with these two things in mind and need to move forward, we played to our strengths and decided to handle the ELT side of this using lambdas. Lambdas are serverless functions, so basically compute from nowhere. And once we started to do this, we realized actually we still wanted to be able to query this data in Athena. So the easiest way to get data into Athena is to use Glue, which we decided to abandon. Fortunately, we didn't have to abandon it entirely. So Glue has the concept of data catalogs. Data catalogs are a reference to are basically the index to the location of your data, the schema of that data, and the runtime metrics. Really, really cared about the schema here. And with our lambdas, it turned out that we could actually use the Glue API to build out these data catalogs and then load them into Athena. This allowed us to just use the one part of Glue that we wanted and still be able to build all of this stuff in a language that we understood and architecture that we were very familiar with. Additionally, aware of our resources, building these, handling the ETL or ELT side of this in lambdas allows our product engineering teams to extend them when we move forwards. So what this means is if we build out a new feature and we want to bring data over from that, these engineering teams can handle them themselves rather than throwing the task over the wall to our data team or having to learn languages that they're less familiar with. So we started building out and experimenting with these lambdas, and then we had to put them actually into the cloud, as you do. Enter infrastructure as code. So classically, infrastructure as code is a huge subject and quite outside the scope of what we're going to talk to today. But effectively, it's an approach to building our IT infrastructure using code as opposed to using a GUI or ClickOps, as it's sometimes referred to. This has benefits like being able to rapidly deploy identical architecture, having source control for your architecture, so i.e. monitoring changes, and everything that's great and hard that comes with code. Historically, at Unmind, we've used a mixture of serverless framework and CloudFormation, but we weren't really confident that either would be the right choice for this. Serverless framework is great, and whilst it's grown massively outside of its original scope, it doesn't really have enough in it for us to be able to deploy the architecture we needed. CloudFormation is also excellent, and we use it extensively, but it's quite low level, and the learning curve for it is really steep. Looking to get something a bit more developer friendly, we settled on using AWS CDK, AWS Cloud Development Kit. This is a relatively new bit of technology. It's only been around a few years, but it allowed us to write our infrastructure in TypeScript. Doing this again, I don't think we would really do anything different here. We would make different choices, but we definitely learned some things. Firstly, if you're going to pick a new approach to infrastructure as code, give yourself a lot more time than you think to use it. It takes quite a long time to bed in with it. We endeavor to follow the principle of least privilege when we set up our infrastructure, giving our code only just enough permission to be able to do things. That, however, finding out what these permissions are in AWS can take some time. You'll find suggested permissions for services across the internet, but if you end up copying and pasting these, you can end up being slightly too permissive. Give yourself plenty of time to deal with this and work this out, and bear in mind it can be really frustrating. Alongside that, it's very easy to conflate the frustration between building out infrastructure as code and actually provisioning services in AWS. Nowadays, when we're building out bigger parts of our infrastructure, we quite often do quick proof of concept using ClickOps, so actually building out the GUI, then before moving to code. This allows us to familiarize ourselves with the service before approaching them with code itself. So the next kind of wonderful learning that we got was the working between either ELT or ETL. So like I said, those letters all mean the same things, but actually they had quite a different effect on us than what we wanted to do. Originally, we were going to go with an ELT approach where the data would have been extracted using our lambdas and then loaded into our S3 buckets. From there, we wanted to create using Athena, which would handle our calculations or our business logic that would, which would have effectively been our transform layer. This would have allowed stakeholders to build reports in QuickSight and our data team to query the data in Athena. Job done, right? Well, we kind of missed a couple of bits. Once the data was in the warehouse, we'd intended to load it into QuickSight in a format called Spice. This is a proprietary format that AWS uses to make it super fast to perform calculations. Unfortunately, as of right now, it's only available. QuickSight is only usable. Sorry, Spice is only usable within QuickSight. This would have meant that we could have generated these reports very quickly, but anything else that we wanted to do with this data, so having our data teams access it and play with it and work out all these wonderful things we could do, would have been really quite slow. Additionally, our data teams had a preference to work in tools that data teams normally work with, such as DBT. DBT is a piece of software that allows you to manage your transforms yourself and store those transforms in source control. So we moved away from the idea of this ELT approach and towards an ETL approach. Now, there's a lot more I'd like to cover here, but it turns out I'm trying to do a 30-minute talk in 15 minutes. So the last thing I'd like to show you is where we've got to now. So we are still building this, but this is currently what we are thinking. Everything in the box on the left-hand side is currently built. On the far left, we have our data sources. Data is taken out of those using lambdas, which are in the middle. Collectively, we refer to them as retina for reasons about letting engineers name things. And then that data is passed through to our S3 buckets. We also have a lambda that builds out our data catalogs. Once you get to the second box, those data catalogs are looked at by a piece of technology called Redshift Spectrum. Redshift Spectrum is similar but different to Athena in that it will allow you to query data in S3. However, it does it in a very different way, which is much faster. It acts as an extension of Redshift, which is a data warehousing solution built into AWS. So on the far right-hand side, we then have our data team and our DBT cloud service. Our data team can now will now be able to run these transformations through DBT, which will pull out the data from S3 using Spectrum, run the transformation, and then load it into our Redshift cluster. So the extract side all happens on the left-hand side. The transform side will happen in our DBT cloud, and then we will load our data into Redshift, which is a much faster and much more suited environment for large-scale analytics. I appreciate that was extremely high level and a little bit quick, so my apologies if I skimmed over anything here. But we are still building this. We're currently at the far right-hand side, and we are hiring extensively through our friends at TechTree and through all other good hiring places So I will leave it there. Thank you very much for your time, and to the organisers, my apologies for going slightly over.
Thanks, Tom. Really, really interesting to listen to your story. It reminds me of some of the challenges we're going through at Tech3. So definitely, I think, having more time than you initially assume is usually useful. So I think, that's something that people often forget about. So thanks a lot. And one question I would have for you, looking back, if you'd be calling the shots, would there be particular things you would want to do differently?
Yes, hundreds. Well, when we got to the end of writing this talk, we realized there's about another 30 or 40 minutes that we could have done on this. I think one of the interesting things to try and work out is how to deliver this kind of thing in an agile way. So how to actually deliver a full data platform in a way that you can take out value early from it. Because they're quite large infrastructure projects, right? You kind of need most of the things in place to be able to do anything. So it would have been interesting if we could have got down to an approach where we could have hooked up QuickSight more early. It would have been interesting to think about if we could have iterated from a data lake to a data warehouse to a data lake and a data warehouse. And I would have loved to have a time machine and get to now and have all this foresight.
Great. And one more question from Ruslan is, Tom, do you parse MySQL binlog for CDC? How do you deal with the schema changes in sources?
So unfortunately, we haven't finished building this yet, is one thing I'll say. So actually, that's a problem that we're still working out. Right now, we maybe look at something like, we're looking at building some kind of smoke test to make sure that these lambdas that actually build out these schema can actually do it in a way that makes sense. But in all honesty, I don't have a full comprehensive answer to that as yet. We're still very much learning, I'm afraid.
Yeah, thanks a lot, Tom. And Lawrence, if you could join the stage, that would be awesome. So the floor is yours.
So yeah, my talk today is going to be about building a COVID-19 vaccine appointment solution in 4 weeks. And just quickly, what I'm going to cover today, so I'll give you a bit of context about who I am and Accurex, the company I co-founded, a bit of context about the vaccine program and why we decided to even do this. And then I've tried to focus in on sort of 5 key pillars, which I think have helped us move fast in building this. And then I'll just touch briefly at the end on some of the challenges we faced and what the future of this product looks like. So who am I? My name's Lawrence. I'm the CTO. I'm one of the co-founders of Accurex. I started coding in September 2013, and feel free to tweet me during or after at Lawrence Bardry. Happy to take additional questions there as well. And where many people here probably won't know who Accurex are, so I'll give you a brief intro to us as a company. So we're a health tech startup. I met my co-founder Jacob on a program called Entrepreneur First back in 2016. We actually started off looking at antibiotic resistance, so trying to make software to make better prescribing decisions for clinicians. And in 2018, we pivoted to look at communications in healthcare. And today our vision is that everyone involved in a patient's care can communicate with each other. So very simple aim to describe, but still quite far from reality at the moment. And just to give you a brief little idea of what the actual things we do are, so our sort of bread and butter has always been text messaging. That's what we started off doing in 2018. We also do asynchronous communication. So this is an example of a patient filling out an asthma survey remotely, but it could also be that a patient is just responding to a question that their GP has asked them or sending a photo back to their GP. And we also do things like video consultations or allowing a clinician to send a document to a patient as well. And more recently, we've been building AccuBook. So this is our product to help book vaccination appointments. This is a view of what the clinician UI looks like, where people can manage cohorts and see if patients have booked first or second doses. And this is what it would look like on the patient end, just sort of a simple booking flow. And to just give an idea of the scale we're operating at, so overall we do about 400,000 texts a day now. We've messaged about half the population. We're used in 99% of GP practices in England. And we've now booked 10 million vaccination appointments. So to give you a bit of the why and the how of when we actually made this decision to work on this product, if we roll back to sort of early November last year, it became clear that GP practices were going to play a key part in helping deliver COVID-19 vaccines. That was alongside sort of mass vaccination sites and jabs in the community. And we very much felt like software was going to play a part in helping here. GPs already do a great job delivering things like flu vaccines, but obviously some key differences here would be the scale of the task and also the fact that there were 2 vaccines, not 1 needed as well, 2 jabs. And we even spent a bit of time sort of crystallizing our thoughts and ended up writing a blog piece about how we thought software and more specifically some of the technology we already had at hand could help. And we then really went back and forth for a few days trying to work out, is this something we want to jump into? We already had 4 product teams working on things at the time. And for us, this culminated in just having a go, no-go meeting. So this was my calendar on Friday the 13th of November, trying to pull a few key stakeholders together and say, what are the pros and cons of us doing this? Do we have the team? What are the sort of second and third order effects on the rest of the business going to be? And ultimately, we decided it was aligned very much with our mission. We had a team who could actually execute this particular challenge, and we were comfortable with some of the other effects. And for us, that then meant we went and asked the team, is this something you want to do? We always make sure that we give the team the choice to decline it as well. And they said yes. And so next Monday, we already started. So this was a virtual whiteboard from the Monday after that Friday meeting. We got all of the team together and we started writing down everything we knew at the time, which wasn't much, and trying to map out what a basic clinician and patient booking flow could look like. And we decided that we wanted to have a mock-up of what the design looked like by the end of that week. And we were going to aim to have patients booking before Christmas. And there were loads of questions at that time as well. So we also ran a user webinar where we tried to gain as much information from them and see how they were thinking about it and give them a chance to ask questions of us as well. So wanted to start getting this product out there. So now I'm going to move on to these sort of 5 key pillars of how we've tried to go from something that's just an idea to release in the space of a month. So the first one is planning for scale. So we knew that we had quite widespread GP adoption and that might lead to this product being adopted quite rapidly. And so for us, what that meant was before even code started being written, we started looking at what a sensible database structure might look like. And so these are examples from Notion pages where we started to look at the classes. We went through example flows of what particular things might look like. And we even went as granular as actual queries and trying to work out, would those be sensible queries given the data structure and amounts of data we would have. We also used, modern cloud infrastructure, so we're hosted on Azure, and we decided to pull out this particular database that hosted all of our sort of appointment data separately from the rest of the Accurx infrastructure. And that really allowed us to do 2 key things. One, scale this database independently, but also meant if there were problems with this particular piece of our infrastructure, it didn't affect all the other things we were doing, so the sending text messages and the surveys. We also used read-only replicas, so we put all of our sort of text message reminders and lots of things that could more do background queries through the secondary database, which left our primary database for things like booking, which has to be up all the time, to be more stable. The second thing is our build and release process. So we've always been very strong advocates of sort of strong code review and pull requests at Accurx. We use GitHub, like many other people will do here. Our VP of Engineering, Ben, has written a great blog post about how we do this. And we always very much encourage people to, A, give an overview of the work and any sort of user-facing elements that have changed, but also for people who are reviewing the code to leave lots of comments to actually check out the branch and go through it. And of course, we make sure that all the associated tests have been run and passed before someone can check in that code. And for us, we use a methodology called trunk-based development. So when a check-in actually does go in, that goes straight into our sort of main branch. It's immediately built and tested again, so no code can actually go out the door that hasn't, again, had everything green. And for us, that goes straight into a staging environment where we can do some manual testing, and that might be the developer who's worked in it or the product manager on the team. And then we can promote that exact version of code from our staging to production environment. And in particular, that promotion aspect has been very useful for us. So I just took a snapshot from a couple of weeks back, and you can see that we tend to be releasing a lot of our components at least once a day, if not multiple times a day. And in particular, in healthcare, that's quite unusual. Things often used to be on like quarterly releases. And for me, this is particularly important because we want to try and minimize the commit differences that are going out each time when we release our software. That means if there is an error, it's easy to roll back, and the rollback's quite minimal as well. So the third part is monitoring. It's something that we've always tried to embrace at Accurex, having a really good understanding of how people are using our products and any sort of errors or warnings they might be hitting. And we made a really deliberate decision early here to embrace quite a high signal to noise ratio. So we wanted to have lots of warnings and errors throughout the vaccine work to make sure we really understood if anything was going wrong. And so to shield the rest of the development team from that, we combined Sentry, which is a piece of SaaS software where you can put all of your warnings and errors through, with Slack. And we used something called root tagging so that all of our logs specifically related to the vaccine product just went to one Slack channel. And that meant everyone else and other products didn't get sort of lifted with these, but also meant we could collaborate really quickly in Slack when we did see errors. And then we could decide, is that actually just an assumption that isn't quite right, or is there an actual user being affected by a bug? We also have some sort of escalations that we would look at. So these are across all of our products, but we tend to be alerted if higher level things go wrong. So we monitor things on the left, like our general ratio of HTTP success codes. And if that drops below 95%, and then your absolute sort of worst case log is on the right, where our uptime robot tells us that the web server is just completely reporting us down. And again, we use Slack to centralize all of these. It was also important to give our product teams a really good idea on this vaccine product of how people were using it. And so very early on, we combined Azure Application Insights with here as a dashboarding so that we understood, how many invites were being sent, how many bookings were being done, the time between someone getting a mobile invite and then actually booking in. And we always try and do this so that our product teams can view these and actually make good decisions given how people are using the product. The fourth pillar is to learn and iterate. And if there's one slide that you take away from my talk today, it's that user feedback is absolutely everything. And for us, a lot of this actually comes from social media. So we were lucky enough that we already had a sort of 6,000 strong Facebook group where we have lots of users in it. And we also had a specific to this product, AccuBook WhatsApp group. And we really try and use those groups to understand if people are seeing any issues, if there are bits of the tool that they're not understanding, and also allows users to share tips with each other. And we try and combine that with a strong user research focus at Accurex, where every product team has a user researcher. In this case, we have Alice, who then uses both the combination of those groups and doing lots of actual usability testing and user interviews to see how people are thinking about things like booking people in for second doses and just get a feel of how people are using the software. The final pillar, which I couldn't go without mentioning, has been the team, who've been absolutely fantastic during this time of intense build. And in particular, I wanted to zoom in on the product manager tech lead relationship. So in that case, this is Jen and Mike, who were the PM and tech lead on this product. And we put a really strong emphasis on this at Accurex. So we almost see these as like co-founders of a mini product team. And we really try and emphasize that they spend a lot of time sort of one-to-one together, and in one-to-ones with their team. We were lucky enough that Jen and Mike had already spent a lot of that time together and building a lot of trust and psychological safety with each other and their team before switching to this product. And to give an example of also Jen's sort of calendar in the morning, you can see she has every morning a catch up with Mike, a general vaccine stand-up where they make sure that the rest of the organization are aware of any changes, in particular our support team or maybe our commercial team, and they also have a team stand-up. And the reason I wanted to zoom in on this is it may seem like a lot of communications every single morning, but when moving really quickly, it's so important that things don't fall between the cracks and that people feel very much in the loop. And so, yeah, that's particularly important for us, is that there's lots of communications in a very quickly moving product. And we've also been incredibly supported by the rest of the Accurex organization. So particularly wanted to look at the support team. This was a slide from one of their recent shows and tell, and you can see here they've had 22,000 conversations in the last 90 days, which is up over double from the previous quarter. And so for us, what that meant was they were responding to lots and lots of queries about how to use the product, and ultimately actually meant we had to grow our support team from 5 to 12 people overnight. So incredible effort by them, both to support the product and to try and hire in really quickly to that team. I wanted to touch on a few of the challenges that we have found whilst building this. The first one is just the wider landscape of the vaccine program and lots of things changing that haven't been in our control. So to zoom in on one example, people will remember sort of around New Year's, the government changed the strategy for the gap between doses from 3 to 4 weeks to 11 to 12 weeks, which has been a great decision. I think it's played out well over the last few months in terms of getting numbers vaccinated. But for us, our original piece of software booked both doses at the same time. And we also had a lot of people already booked for second doses in early January. And so this particular announcement meant pulling people off annual leave just before New Year's. And we had to quickly change the patient booking flow to only book one dose and change the clinician software so that they could mass cancel lots of second doses. So just a quite challenging time for the team and something we had to turn around in sort of 48 hours. The second one has been the tech eventually breaking. So this is a lovely graph from when our database did hit 100% one particular day. So whilst we tried to make a lot of those intelligent decisions up front and we did try and plan for scale, we've had to release so many features and tweak the product so much as things have changed. The technical debt eventually does catch up with you. And it's been a real learning for me of how quickly, if you don't have parts of your sort of sprint process paying some of that down, it can catch up with you. And so now we're trying to go back and change some of the user flows, the way people interact, and particularly on the clinician side, to make sure this doesn't happen. The good thing is if you do use cloud technologies, it's very easy often to scale and give yourself that bit more leeway. And the final challenge for us has been team burnout. It's fair to say it has just been a workload that's been quite unmanageable for quite a long time for the team. It's not something that we'd ever want to impose on the team. And in particular, at Accurex, one of our values is actually balance. We really believe that people do their best work when they're happy and healthy outside of work, and that whilst you may need to occasionally sprint, that shouldn't be over a sustained period of time. And so for us, really here, the challenge is now moving into that more sustainable way of working again and giving the team some time back for the extra effort that they've put in. Finally, I just wanted to touch on what the future looks like for this product. So the first part is that we'd love it to be used for September jabs. It's becoming clear that probably people who are vulnerable will need a booster dose in September. And so we'd hope that we could keep the product going and enable continued efficiency in rolling that out. Second part is that we're currently developing some recording software. So whilst we've just focused on the booking software, we are actually also developing software when you go to have your vaccination that helps someone record it. And so we're hoping to put those together to have an end-to-end booking and recording flow and release that over the next couple of weeks to continue to make the product better and ultimately the lives of people doing the vaccinations that bit easier. And the final part is that these COVID vaccinations, whilst there are lots of things that have been particular about them, this actually is part of a general sort of problem called recall. And our product team that's working on this will be looking in the future to how we can take lots of the elements that we've developed in terms of cohorts, getting people in for particular times and dates, and then applying that to things like flu jabs, smear tests, cancer screenings, lots of problems where you need to get a cohort of people and pull them back in. And that's it. Really love to speak to you today. We're, like many people here, hiring across lots of roles at the moment. And we're going from sort of 80 overall to about 150 this year. Lots of those roles are engineering. So feel free to check out our careers page. And again, feel free to tweet me at Lawrence Bardry.
That was so exciting to listen to. It was like, watching like untold story of, what has been happening in this country and around the world for, last 6 to 12 months. One question I would have is like, from your perspective, like how quickly have you had to react, and kind of like how was it changing, the business strategy that was in place, sort of, February? Because I think, I think you've doubled in size since the COVID started. And I imagine it has been, huge shift for the business. So kind of like, from a sort of a co-founder, but both the sort of, CTO perspective, someone who's, looking at the roadmap, etc. Like, can you maybe give a bit of insight in terms of like how you were making that decision and what was the impact?
Yeah, I think in terms of the impact in particular on strategy, I think specifically technically, it's not changed a lot of the strategy, and it's just slowed some things down. So we've been migrating to, for example, Kubernetes to host all of our infrastructure over the last sort of 6-9 months or so. And so that's just, this piece of work has more just slightly slowed that down as attention has been drawn onto it. I think in terms of the overall business strategy, it has not long-term shifted it, but obviously taken up a lot of our product team and myself and my co-founder's headspace for many months now. And if this hadn't come along, it definitely is the case. There would have been product teams working on other things that were probably slightly more closely aligned to our sort of long-term vision. But it's been, very, very rewarding to work on. And as I said, we're hoping that it eventually becomes part of our sort of like wider platform offering in terms of recall, and still is very aligned with our mission of better communication with patients. But yeah, has certainly been a large deviation, and like a lot of these things, a sort of a deviation for longer than we originally thought. You go into them thinking this will just be 6 weeks and we can get back to what we were doing before, and obviously it never pans out that way.
Amazing. Great. So thanks a lot, Lawrence. And our last speaker is going to be Craig. So Craig, feel free to join the stage. There you go.
Hey there.
So the floor is yours.
Sure, fantastic. Thank you, Lawrence, for that. And thanks, Pablo, for a smooth transition. Today, I'll be talking around event sourcing, which is I guess it's an old but new way of building applications. I'll talk about what it is, try to get the concept in your mind, and why you might want to use it for your next project. We've been using it in production for around 4 years now at Superscript, so I'm going to mix in a few stories from the trenches in there. I think it's good to share these sorts of stories, and Lawrence did that as well with his database CPU usage. It's good to share mistakes to help others learn and try to avoid them in the future. And more importantly, that it's okay to make mistakes every now and then. This is our sort of description of the tech within Superscript. We're a B2B insurance company. We've got tech which intelligently places customers' risks with different carriers, and we have the ability to move that risk between carriers as we see fit, so that they get the better deal. In addition to that, we offer the business insurance on a monthly basis, which is something that's not seen too much in the industry, and we're sort of translating that monthly concept to the annual concept, which is a little bit challenging with rounding issues and whatnot. And the insurance industry is quite a rich domain, which is what led us to using this event sourcing architecture in the first place. I've been at Superscript for around 3 years now. The company's around 5 years old. The CEO, Cam, is tech as well, so he actually built the first version of our system, and I've been setting up the tech team and setting the engineering culture with us. And so one of our core values is the developer experience, and I really like to describe that as a low pain tolerance. So if there's like intermittent tests failing, or the tests are slow to run, or deploying is slow, you don't have like dedicated environments to test particular features, we really make that a first-class principle to remove that pain from our day-to-day work. Our tech stack is mainly based around Laravel and Vue, hosted on Heroku and Netlify. So it's sort of avoiding AWS and its complexities, like trying to keep things as simple as possible so we can keep that developer experience up. Event sourcing is more of a generic concept. It's not tied to a particular language or stack, and it's probably more popular in the .NET or Java world, but we're using it in the old school PHP, using the Laravel framework. So yeah, I'll get into what event sourcing is. The best way I've seen it described is it is to data what Git is to code. So for the seasoned engineers out there, updating code on a server used to be like yelling out in the office, "Oh, I'm editing the user's file, don't touch it," and then we would make our changes and upload it. And there was no real version control of our code aside from the odd backup of the server. We think that's crazy today. Like, we've got tools like Git and version control and all these CI and CD tools, and to think of this way of doing things just seems a bit mental. But we're kind of doing this with our databases already. So we might have a simple order table, and we are just issuing an update SQL statement, which is basically overriding a value, and we're losing the transition. We're losing the transition of an object and its life cycle and its history over time. So event sourcing solves this in a rather elegant way. I'm just going to take it back to Git for a sec. So just to remind ourselves on how that works, I'm sure we're all familiar. You start off with a blank repository, and then you layer on commits with diffs, and each commit has a description. It has the diff of the code that's changed. Then it has metadata about who committed that change and when it was done, and the commit hash and so forth. Event sourcing is pretty much exactly the same, but for your data. So you start off with like a created type event. You've got the type of event that's happening, which is your sort of like your commit description, and then you've got the payload of data, which comes with that event, which is sort of like the diff, and then you've got created date and the event number and things like that. So I hope that instills like the concept of what event sourcing is in a very high level way. But you can see already the benefits of Git are automatically applied to the data now. We've got a full version history of our objects as like a first-class principle, and we can go back in time. So we could just roll back our events to a particular version and see what our data was at a certain point in time. There's some other Git concepts like branching in the event sourcing world, where you can do like what if scenarios and like inject events lower in the stream and then see what happens in the future. But they're a bit out of scope for today, and they're a bit more advanced topics. So yeah, hopefully that makes sense. Like any tool, you can use it in the wrong way. So I'm not sure if you have commit rules at your work, but occasionally if we're like spiking out a new feature or something, we will do the whip commits and the dot commit and the fix issue and the revert. You can do similar things in event sourcing, like if you were just using very generic event descriptions, like just create, update, delete. It's not really useful. You're not using the power of event sourcing. So I'll get into our first war story. So this happened when I first joined Superscript, roughly, well, this happened about 2.5 years ago. I was doing some refactoring, changing the events around, and using that feature of replaying events to rebuild our database. But I accidentally left one of the event listeners live and actually charged a fair few of our customers twice for their policies. So that we learned a big lesson there, not to have any side effects when you're replaying events. So keep that in mind if you were to implement this pattern. So I guess there's lots of reasons to use event sourcing. I just want to pull out my two favorite ones. The first one is all around like domain-driven design and capturing the business intent and really modeling what your business is within the software and the code that you write. So just as an example, I touched on previously, we might have an order table that went from pending status to paid, and the outstanding balance went to 0. But we've sort of lost why that had happened. It could have happened from an API call to register a payment, or it could have been a discount that's been applied to the order. Without extra tooling and infrastructure and tables and stuff like that, it makes it hard to just look at the order and see what's happened. So with event sourcing, these events, the state transitions for your objects are treated as like first-class citizens, and so you can easily see the timeline of your domain objects and how it works. And so these events are like stored as structured objects in your code, so you can really model the processes that are happening in your system, rather than like translating that into a post request to a payments endpoint with a particular order ID. You don't lose that through this modeling process. The why number two, we've probably all worked in systems which grow in complexity over time, and event sourcing is a great way to split up your domain objects into different concerns. We've probably all built a CMS. It's part of a rite of passage in learning to become an engineer. I know I've done it previously. So just wanted to pull out like the concept, an example of a page object in a CMS. It might just start out with a title field and a content field, and they're the content concerns, and that works well. We've got a blog up and running and starting to gain some traffic and popularity, and we want to start adding analytics to our model. So we would naturally go into the database, add some new columns about the number of times that page has been viewed and the average read time. And then we want to start collecting user information. So we'll add some forms and we'll add commenting onto the page. And that page model in your code is starting to grow and grow and grow and grow. And it starts to become a bit unmaintainable. So what event sourcing does is it separates your write concerns from your read concerns. And it really allows you to split up these large domain objects into individual bits and really encapsulate specific events that are going to happen instead of like just chucking it all into the one table. So usually you would have a one way to write to your object and the different methods that you can do, and then you can have one or more read models which are purpose built for particular things. So this way you can keep your pages table in your database just as title and content, and it doesn't have to worry about all the analytical concerns. And you can set up other areas in your database which only have analytical data, so they're purpose built for that, for reading data, which is really good for scaling in the future. In addition, you could write event listeners which send stuff to Elasticsearch or other analytical platforms to really create those really optimized read models. So this one happened, my next war story happened not too long ago. We did the Ghostbusters thing of crossing the streams, essentially. So we've got two different event streams, and they both went into the one database in production, and then further events were raised from this mixing of streams. So there were IDs mixed between environments, so that was a bit of a pickle to sort out. It was sort of like separating sand from dirt, but we got there in the end, and we had some data tests to verify that. So I guess this is more of a no-brainer to not mix your environment configs in the future, especially as your infrastructure gets a bit more complicated as the business and the system grows. Just one last thing. If I've confused you in any way, or you think that having all these different database tables and the read and write concerns are separated, I just wanted to highlight that these concepts sort of exist already in right across the stack. So in the front end, we've got Redux for React and Vuex for Vue, where you sort of commit mutations, which are like the events, and then the read model is the state, which is what your component is rendering to the browser. GraphQL is clearly separated between mutations and queries. REST APIs have the post, patch, and delete as to deal with your write concerns, and the get method is meant for your read concerns. And even databases, which have been around for decades, you might store your core model data in simple tables, but your read model might be these really complex SQL queries, which you might create as views or materialized views. So it's and I think my takeaway from this is that this stuff has existed at a technical infrastructure level all this time, but what event sourcing does, it really raises it to the surface so that this write and read business concept is raised to the I guess, the software design or the business level, rather than being a technical implementation concern. So yeah, that's sort of it in a nutshell. So I hope I've distilled the concept of event sourcing and why you would use it in your next project. There's tons of material out there on the internet if you want to get involved, and if you want some pointers, feel free to get in touch, and I can share my learning journey as well.
Thanks a lot, Craig. Really interesting to listen to that. And I don't think we have any questions, but guys, if you have any questions, you can also reach out to Craig on LinkedIn. It's been an exciting afternoon, and so interesting to listen to these stories and the challenges that people have. And I think we've had some great questions too. So thanks a lot to all the speakers. We've really enjoyed it, and thank you for your time. And it's been another great event.